Hi guys, welcome to this very first tutorial in this series of programming PIC microcontroller with MPLAB XC8. The aim of this course is to teach you how to develop microcontroller-based electronic systems using microchip XC8 compiler. As some of you knows already, MPLAB XIDE is the new MPLAB, is the new microchip IDE, and this time it runs on Windows, Mac, or Linux operating systems. This IDE replaces all the previous MPLAB C and high-tech compilers. XC8 is the new compiler for all the 8-bit PIC microcontrollers. These include all the PIC10 series, PIC12, PIC14, PIC16, and PIC18 series. You can download a free copy of MPLAB XIDE and XC8 compiler from Microchip website. If you go to microchip.com, hover under the product and click MPLAB XIDE. In this section under download, you can download the latest MPLAB XIDE. You can also download a free version of XC8 compiler, XC16 if you're gonna develop 16-bit microcontrollers like PIC24 series or DS-PIC, XC32 for all the 32-bit PIC microcontrollers. In our case, we're just gonna download MPLAB XIDE and MPLAB XC compiler. Once you've downloaded and installed the IDE and the compiler, you can go to Start and start MPLAB XIDE. When it opens, you can come to File, Start a new project, or you can just click on this icon to start a new project. I'm gonna click New Project, select Standalone Project, Next. Select the family of the PIC you're gonna use. In our case, we're gonna use a PIC18 series, so we're gonna select Advanced 8-bit. Select the device that you're gonna use. In our example, we are going to use the PIC18F 2220. It's a small PIC. It's got an internal oscillator, so we're not gonna need any external component except the LED and the resistor. Click Next. Select the programmer you're gonna use. We're gonna use PIC-Kit3. Next. Select the compiler. As we've already installed our XC8 compiler, select XC8. If you had other previous versions or other compilers, MPLAB compilers, they're gonna be listed here as well, like C18, high-tech. Okay, gonna use XC8, click Next. Give your project a meaningful name. I'm just gonna call it XC8, make it short and simple. Select the location where you're gonna store it. Just gonna leave it in a default directory and click Finish. The first thing we're gonna need to create is the header file for our project. The header file is where we're gonna set all our configuration bits. Under the header file, right-click, New, C header file, give it a meaningful name. I'm just gonna use the same name, XC8. To the location, I'm just gonna leave it in the same location as the rest of the project and click Finish. I'm not gonna need any of this default, so I'm going to delete everything. Here you can put a small comment. Setting the configuration bit is very important. If they are not correctly set, the processor will operate in an unknown manner or often not start even at all. The easiest way to set the configuration bit, to go to Windows, pick Memory View, and click on Configuration bit. We just drag this a bit so we're gonna be able to see properly. This is where you're gonna select what you need and what you don't need. To have a picture of what we are going to do, let's go back to our circuit diagram. This is our circuit diagram. We've got the PIC 18F2220, and the other two things that you should consider in this circuit is the oscillator section and the reset section. In our oscillator section, we are using an external 8 MHz crystal oscillator. And in our reset section, if we need to reset our microcontroller for some reasons, then we can press this push button and the microcontroller will be reset. In normal circumstances, the MPLAB pin of the PIC microcontroller requires a positive 5 volt. As you can see, if this push button is open, then we're gonna have a path of current from the positive supply to the microcontroller MPLAB pin. But if the push button is pressed, as the current always follows the path with the least resistance, all the current is gonna flow from the positive supply to the ground. To make everything simple for this first tutorial and in the most of the future tutorials, we're not going to use an external oscillator, as the PIC 18F2220 has got a built-in oscillator, so there is no point of wasting extra money for an external oscillator, 2 capacitors, while the PIC has got its own internal oscillator. So we're going to delete this section, delete. For this first tutorial, there is no need to reset the microcontroller, so I'm going to delete this reset section as well. Gonna delete. Okay, delete. This is a nice feature to use, especially to save some more pins. As you can see, pin RA6, pin RA7, and pin RE3 could be used for something else. In the code, I'm going to enable RE3 to become a general input-output pin, and I'm going to enable the PIC to use the internal oscillator. So RA6 and RA7 could be used for something else. Let's go back to our code. The rule of thumb is always switch on only what you are going to use and leave off everything else. It's always recommended to disable the low voltage programming unless low voltage programming is required to prevent possible processor reset. The watchdog timer should also be disabled, since an infinite loop will be used unless needed. So in our case, we are going to select an internal oscillator. Click on internal RC oscillator, port function RA6 and port function RA7. Failsafe clock monitor, we're not gonna need it. Internal, external switch, blah blah, we're not gonna need it. This one is already disabled. Brownout reset, we're not gonna need it. Watchdog timer, we're not gonna need it. And the last important thing is the MCLR. Let me disable it. If you don't disable it, your circuit is gonna keep on resetting. I'm going to reset it because there is no need for us to disable our project. Once you're done, click on Generate Source Code to output and copy the generated code. Copy and paste it on our header file. Paste. The last thing before we finish our header file is to set the frequency of our oscillator. To do this, just gonna say define underscore xtol underscore frec 8 meg. Okay, let me save. It's always a good idea to keep on saving. And we are done with our header file. The next thing is to create our C main file where we're gonna write our program. Under the source file, right click, new, C main file. I'm going to give it the same name, XC8. Gonna leave it in the same directory. Finish. The first thing before we forget is to include our header file. To do this, I'm going to say include xc8.h, and here we can write the content of our program. I'm just going to stop. I'm going to pause this recording, then I'm gonna write everything, and then we're gonna come back to it. Okay, this project, it's really simple. The first thing is to set our port B0 as an output, because this is where we're gonna connect our LED, and set our OSCON register to use an internal oscillator at 8 meg. Create a while one loop, a continuous loop, so that our LED can switch on and off continuously. And one line of code can really do it. Let b bit dot let b 0 equals to complement of let b bit dot let b 0. Basically, I'm just complementing whatever value is on let b. If on port B, you can use port B or let b. It's always good to use let b if you're using the PIC 18 series when you are outputting, and when you are reading, then you can use port B command. As we are outputting, I'm going to use let b. Initially, let b 0, the complement of 0 is 1. Then I can create a small 1 second loop. Then once it's gonna loop back again, I'm gonna complement the 1, which is gonna be 0. Basically, I'm sending 0, then 1, 0, then 1, continuously at an interval of 1 second. Once you are done with your project, with your code, click on Build Main Project to generate your X file that you're gonna transfer to your PIC. And if there is no code, there is no error, everything is gonna build, and you're gonna get a message. Okay, still building, still building. All right, build successful. It means there is no error. And we are done for our project. Let's go back to our circuit. In this simulation, we need to load our X file. Right click on your PIC, edit properties, browse, Select your project XC8 under DST, open and select our XC8.x file. Click open. Okay. And I can test play, and as you can see, our LED is flashing on and off. Thank you for watching, and don't forget to subscribe our YouTube channel to receive more tutorials in the future. Thank you.